My dear students, welcome back. So, in this class, let us first discuss about skews theorem. Skews theorem. What is skews theorem? The theorem states that suppose sequence xc or x equals xn and y equals yn are any two sequence of real numbers. Also, sequence zn, x equals xn, y equals yn and z equals zn be the sequence of real numbers such that xn less than or equals yn less than or equals zn for all n falling n. Let limit xn equals limit to zn. Limit xn equals limit to zn. Then sequence yn converges. Sequence yn converges and limit xn equals limit yn equals limit z. Limit xn equals limit yn equals limit z. So this is the skews theorem. Sequence xn, yn, zn are sequence of real numbers with xn less than equals yn less than equals zn for all n falling n. If limit xn equals limit zn, then sequence yn converges and limit xn equals limit yn equals limit zn. How? So given xn less than or equals yn less than or equals zn for all n falling n. Now let limit xn equals a. Also it is given limit xn equals limit yn, so limit xn equals limit z. Means let limit xn equals a as well as limit zn equals a. Limit xn equals a means for all epsilon positive there exists some k1 fallen n such that modulus of xn minus a strictly less than epsilon for all n greater than or equals k1 by definition. Again, a equals limit zn. That means again for all epsilon positive there exists some k2 fallen n such that modulus of zn minus a strictly less than epsilon for all n greater than or equals k2. So put on k equals maximum of this k1 and k2, then the above two conditions, above two equations are held for n greater than or equals k. Mod xn minus a less than epsilon for all n greater than or equals k, as well as mod zn minus a less than epsilon greater than or for all n greater than or equals k. Now, it is given xn less than or equals yn less than or equals z. But modulus of xn minus a less than epsilon, modulus of xn minus a less than epsilon means it is a minus epsilon less than xn less than a plus epsilon. Okay, that is minus epsilon less than xn minus a less than epsilon. After that a minus epsilon less than xn less than a plus epsilon. Similarly, again mod zn minus a less than epsilon. That means a minus epsilon less than zn less than a plus epsilon. So these two are held for all n greater than or equals k. Agree. But what is xn? xn less than or equals yn less than or equals zn. Come to this condition and combines these two conditions. So we have a minus epsilon less than xn, but xn less than or equals yn less than or equals zn, but zn strictly less than a plus epsilon. Okay, that means a minus epsilon less than yn less than a plus epsilon. That means modulus of yn minus a strictly less than epsilon for all n greater than or equals k. For all n greater than or equals k implies sequence yn converges to a. Sequence yn converges to a, but let limit xn equals a and limit zn equals a. So from here we say that limit xn equals limit yn equals limit z. So this is our conclusion. So this is the skews theorem. Sequence xn, yn, zn are sequence of real numbers if limit xn equals limit certain, then limit xn equals limit yn equals limit certain whenever xn less than or equals yn less than or equals certain. Okay, right. So, by using this theorem, we consider a problem. Limit sin by n equals 0. Prove that limit sin n by n equals 0. Sin n by n equals 0. How? So far, we know that the maximum value of sine function is 1 and the minimum value is minus 1. So we have minus 1 less than or equals sin n less than or equals 1. Clearly, that implies minus 1 by n less than or equals sin n by n less than or equals 1 by n. So, but let secant xn equals minus 1 by n and yn equals sin n by n, comma zn equals 1 by n. Consider these two sequences, these three sequences. Xn is minus 1 by n, yn is the middle term, and zn is the last one. So what is limit xn? We have limit xn equals limit minus 1 by n is 0, as well as what is limit 1 by n is limit zn. Limit zn equals limit 1 by n, that's also 0. So limit xn equals limit yn. Moreover, xn from here, by the choice of xn, yn and zn, we have xn less than or equals yn less than or equals zn. So the two conditions for the skew theorem are satisfied. By limit xn equals limit zn, moreover xn less than or equals yn less than or equals zn. So according to the skew theorem, we have limit xn equals limit yn equals limit zn. But what about limit xn? That is 0. Limit zn 0. So from here, what is limit yn? Limit yn equals 0. What is yn? Means limit sin n by n equals 0. So this is what we require. Enough. Now there is another result. Let the secant xn be a sequence of real numbers, and if secant xn converges to x, then mod xn converges to mod x. If secant xn converges to x, then secants of mod xn converges to mod x. Secants of mod xn converges to mod x. How? Let's imagine it. Why? For secant xn converges to x means for all epsilon positive, there exists a natural number k such that modulus of xn minus x strictly less than epsilon for all n greater than or equals k by the definition of convergence. Now, we have to show that modulus of xn converges to mod x. How? Consider modulus of mod xn minus mod x. Modulus of mod xn minus mod x. We know that modulus of mod xn minus mod x less than or equals modulus of xn minus x. But modulus of xn minus x strictly less than epsilon for all n greater than or equals k. Ultimately, modulus of mod xn minus mod x less than epsilon for all n greater than or equals k. That means mod xn converges to mod x. So the proof is complete. Now, come to another one. Let the secant xn being a sequence of positive real numbers. Sequence of real numbers. Let xn being a sequence of positive. What are we? Let secant xn be a sequence of real numbers which converges to x. Moreover, limit xn greater than or also xn greater than or equals 0. Also xn greater than or equals 0 for all n falling n. Let the secant xn be a sequence of real numbers which converges to x, and xn greater than or equals 0 for all n falling n. Then root xn converges to root x. Root xn converges to root x. So how? Given xn converges to x, xn converges to xn means by definition for all epsilon positive there exists a real number, so there exists a natural number k such that modulus of xn minus x strictly less than epsilon for all n greater than or equals k. But xn greater than or equals 0, given xn greater than or equals 0, xn greater than or equals 0 means limit xn, that is for all n fall in n, that means we already proved that when xn greater than or equals 0, limit xn greater than or equals 0 for all n fall in n. This is a non-result. Limit xn greater than or equals 0 means what is actually limit xn? Limit xn is x. According to our assumption, limit xn is x. Therefore, x greater than or equals 0. Therefore, x greater than or equals 0. Now, if x equals 0, first condition, if x equals 0, we have xn converges to x, but what is x? X equals 0. That means modulus of xn minus 0 strictly less than epsilon square for all n greater than or equals k for n. Since xn converges to x, here x equals 0, so for all epsilon is positive, then modulus of xn minus 0 less than epsilon square for all n greater than or equals k, that means mod xn strictly less than epsilon square, modulus of xn strictly less than epsilon square for all n greater than or equals k. So that means root xn, since xn greater than or equals 0, since xn greater than or equals 0, it is xn, mod xn means xn less than epsilon square. Therefore, root xn less than epsilon for all n greater than or equals k. That means modulus of root xn minus 0 strictly less than epsilon. That means root xn converges to 0. What is 0? 0 means root x. When x equals 0, root x equals 0 for all n greater than or equals k. That implies root xn converges to root x. When sequence xn converges to x, then root xn converges to root x when x equals 0. There exists another case. Suppose x is positive. When x is greater than 0, what happens? Come to the second argument. When x is greater than 0, come to the second possibility. X is greater than 0. So you can consider root xn minus root x. Root xn minus root x equals, it is root xn minus root x into, you can multiply in both the numerator and denominator by root xn plus root x divided by root xn plus root x. What is the numerator? So that means root xn minus root x equals, it is of the form a plus b into a minus b. It is xn minus x by root xn plus root x. So xn minus x by root xn plus root x strictly less than xn minus x by root x. Agree? Yes, xn minus x by root x. But xn converges to where? Xn converges to x. Xn converges to, but it is given secant xn converges to x means for all epsilon positive there exists a k following en such that modulus of xn minus x strictly less than some epsilon into root x. Since root x is positive, since x is positive, we know that root x is positive. Epsilon is positive, epsilon root x is also positive. So modulus of xn minus x less than epsilon root x for all n greater than or equals k. Therefore, therefore root xn minus root x strictly less than xn minus x means epsilon into root x by root x. So it is modulus of root xn minus root x strictly less than epsilon. That means root xn converges to root x. So when x is positive, the result also occurs. That is, let secant xn be a sequence of real numbers, then xn converges to x, then root xn shall converge to root x. Enough. Okay. Now, by using these arguments, we consider some problems. So first we prove that secant n is divergent. Secant Cn is divergent. What is divergent? A sequence which cannot be converged. How to prove the sequence n is divergent? If possible, the proof is done in this way. If possible, sequence n converges. Secant n converges. Secant n converges means there exists a real number m such that there exists a real number m greater than 0 such that n equals mod n equals mod n, that is strictly less than m for all n fallen n. Okay. If sequence n converges, n be a secant, n be a sequence of real numbers, then when it converges, there exists a real number capital M which is positive such that n equals modulus of n, that is strictly less than m by the definition of convergence. But by Archimedean principle, what is Archimedean principle? For any x Archimedean principle, that is that x fall in R, then there exists a natural number nx such that x strictly less than nx. But here n is a natural number strictly less than that real number, so means that's a contradiction to the Archimedean principle. This contradiction is due to our wrong assumption, therefore sequence n diverges. Okay, if you take secant n converges, if you assume secant n converges, then you will reach a contradiction. That contradiction to the Archimedean principle, that contradiction is due to our wrong assumption, hence secant n converges. Agree. Now what about the sequence minus 1 by n? Minus 1 all power n. Sequence minus 1 all power n. To prove sequence minus 1 all power n is divergent. How? If possible, sequence minus 1 all power n converges to a particular number a. If possible, sequence minus 1 all power n converges to a. So what do you get? That means for all epsilon positive, there exists a natural number k such that modulus of minus 1 power n minus a strictly less than epsilon for all n greater than or equals k. Okay? Then there are two possibilities. Suppose n is odd. When n is odd and put epsilon is 1. Put epsilon is 1. When n is odd and put epsilon is 1. When n is odd, what is minus 1 power n? It is minus 1. So this relation 1 become, when n is odd, it has become modulus of minus 1 minus a strictly less than 1. Minus 1 minus a less than 1 means minus 1 less than minus 1 minus a strictly less than 1. If we add in 1 on both sides, 1 minus 1 0, so it is 0 less than minus a less than 2. 0 less than minus a less than 2 means again 0 greater than a greater than minus 2. By multiplying forward by negative, so you have, if you multiply by negative, the inequality reverses, so it is minus 2 less than a less than 0. 0 greater than a greater than minus 2 means minus 2 less than a less than 0. Agree. If n is even, what happens? When n is even? When n is even, equation 1 becomes, again put epsilon is 1, equation 1 becomes modulus of 1 minus a strictly less than 1. Okay, that for all n greater than or equals k. That means 1 minus 1 less than 1 minus a less than 1. You can add in minus 1 on both sides, so it is minus 2 less than minus a less than 0. That means multiplying throughout by minus, so it is 2 greater than a greater than 0. 2 greater than a greater than 0 means 0 less than a less than 2. Okay. So come to these two conditions. One is minus 2 less than a less than 0 and other is 0 less than a less than 2. So a does not satisfy these two conditions simultaneously. That means it does not converge to a. That means sequence minus 1 power n always diverges. So sequence n is a divergent sequence. Secant minus 1 power n is also divergent. Agree? So, first you consider the skews theorem, and then by using the skews theorem we prove that limit psi n by n equals 0, and come to other conditions of the convergence. Now, also we discussed two problems, sequence n and sequence minus 1 power n are divergent sequence. Okay, thank you.